Okay, so today we'll be looking at this equation, 9 to the 4x equals 5, part C here. Let me just rewrite that, 9 to the 4x equals 5. Yeah, that 4x is a little small. And we're just trying to solve this equation. And from a previous video, I solved parts A and B. With those two problems, we could set both of the bases equal to each other, okay? So for example, for A, the base of both sides of this equation would have been base 2, and then for B, it would have been base 5. Okay, for this question, that's not possible. You can try as much as you want, but if you want a nice integer for a base, that's not going to happen, all right? So what do you do to solve a exponential equation where the bases are not the same? So the technique is to use logarithms, okay? So what we're going to do is we're going to quote unquote take a log of both sides. And this log can be any base that you want. It does not matter, okay? As long as the base is positive. That's what we care about. And I'm going to go ahead and choose base 9. And what happens is as such, there's a property that says if you take the log of where base whatever b, but the expression is an exponent where the base is b, like you have here, then the only thing you get out here is the exponent. That's your answer. That's what it simplifies down to. And then we kind of think like it cancels, something along those lines. So in our case, where we have the log base 9 and 9 to the 4x, all you have left is the 4x. That's what this becomes. So this would come straight down. That's 4x. Then on this other side, you have log base 9 of 5, which we can't really simplify as much. We can approximate it, but that's about it. And I'm going to go ahead and divide both sides by 4. And that's it. Your answer would be log base 9, 5 of 4. One thing I forgot to mention, but make sure when you're solving an exponential equation, you have just a number constant on the other side. That number needs to be positive. If you had, -5, then there's no point of going forward with this problem. It would be done. There's no solution. So if you have an exponent equal to a number, the number must be positive. Now, as I said, you can pick any log base as long as the base is positive. Your most popular choices, though, are usually base 10 and base e. And that has to do with the fact, at least a few years ago, that calculators can only work with base 10 and base e. If you have a graphing calculator, I don't think that's so much the case now. They can take logarithms of any base. But back in the day, you can only do base 10 or base e with a calculator for sure. And a lot of the time you'd also be asked to approximate the solution to this equation. So you only had a choice base e or ln or log base 10, which is log. Now this still rings true for some calculators. Like if you have a scientific calculator, I think those still have like just log and ln as the basis. But anyways, if I were to say, let's say we took ln instead, this is what we would have. And here we don't have a cancellation property, but you do have a property of logarithms which says that you have a log of a exponent, the power, the 4x, can come down in front. And I could solve for x here by dividing both sides by 4 and ln 9 here, 4 ln 9. Okay. So that looks kind of strange because the x is right in the middle, but yeah. And that's it. That's your answer. Okay. All right. And yeah, you could do this with base 10 as well. We just log on both sides, and the steps that I did here with the ln would be exactly the same. So your answer would be like log 5 over 4 log 9. Okay. All right. Thanks for your time.